This is exercise 6, and we're looking at predictive modeling with regression. So first we're looking at exercise 6.1, so we're creating a simple linear regression within SAS-Viya using the exam data set. So going over to SAS-Viya, you go in, explore and visualize, and use the exam data set, you put in linear regression, and then from there, you can see that response is going to be the target, which is exam mark, and then the predictor is going to be hours of revision, which is the continuous effect. And then you can see that this is what happens when you input it. You are looking at, we want to verify that within this little table right here on table 6.9, that r squared equals 0.59. So going back over here, you can see that r squared does equal 0.59. You want to see that the MSM is 221.13. So you do that by going over to the overall ANOVA, and you can see that it does in fact equal 221.13 when rounded. You are also looking at the MSR value, which is going to be 19.101. So going back to here, you're going to find that it does right here in the mean square error, 19.01. And then looking at the F value, you want it to be 11.57. So going back, you can see that the F value is in fact 11.57. For the second part of exercise 6, we are going to go back to SAS-Viya, and we are using the advertising data. So as you can see, we are using sales as the response this time, and the continuous effects is radio. So looking into this, we're wanting to create the regression equation. So we do this by stating that sales equals this estimate in the radio column right here, so 68.98 times the number of ratios plus the estimate from the intercept, which is 289.97. So the regression equation, it would be 800 radios equals this number right here, 68.98 times the 800 again, plus the 289.97, which is going to roughly come out to around $55,473.97. And then you're looking at this number right here to be the p-value. And basically it's saying that radios are a significant predictor. So we're then going to want to look at the adjusted R-square value. So if you go down through right here, I just passed it. The adjusted R-square is it is 0.312801. This in the end shows that this model is not significant. For the third and final part of exercise 6, we're looking at multiple regression. So went into the into SAS-Viya again, using the same advertising data. This time, instead of looking at one, we're looking at 3 different things right here. So we're going to make sure this is looking at the R-square value. So for the roles, the response is still sales, but the continuous effects, there are 3: press, radio, and TV. We were then asked to add an interaction effect between TV and radio. So you do this by going over to new data item and interaction, and from there you click TV and radio, and then you come over to the right pane and you add it into the TV and radio, or you add TV and radio into the interaction effects, and it sort of gives it a new look compared to what we had seen before. Now, looking at this data, it's then asks us to find the new regression equation with this. So I'm going to close out this side and go right here. So the regression equation is going to be 4.22, which is found right here under TV, times the number of TVs plus 64.02 times the number of radios, and then plus 32.63 times the number of press, and then minus 0.01, which is right here, times the interaction effect, which was the TV and radio, and then you're going to subtract this intercept right here, so 190.24, and basically the interaction effect is not really significant in terms of this data set. Then we are now looking at the R-square values between the baseline and then the new model statistics. So you can see right here that the R-square for the baseline is 0.647445. And then going out of this, we're going to go to the new model, and we're going to look at the R-square value for that under fit statistics. And you can see that the R-square value is 0.647448. So looking at the R-square value, there is a very minimal increase from the baseline to the new model. But then when looking at the adjusted R-square, you can see that the adjusted for the new model is 0.641692. And then going back to the baseline, you can see that the adjusted R-square under fit statistics, if I can get it to stay for me, is actually higher than the baseline, or than the new model. The adjusted R-square value is 0.643146.